Hello, it's James from xrobots.co.uk. This is part 25 of Ultron, the Real Robot. The aim of this project is to build Ultron as a real robot, and we've done most of that in the previous 24 parts. So now comes the fun stuff, which is building the AI. So Ultron is going to be driven by its own brain, which is going to be a piece of hardware dealing with sensor input from a motion capture suit, and essentially making it react in a social environment. So last time we installed some mood lighting and also some force feedback sensors in all of the shoulder joints, so Ultron can tell if someone pushes it or shoves it or tries to move its arms around. It can also tell if it collides with something. We've got many more sensors to include, including vision, and today we're going to work on trying to get Ultron to react to some of that sensory input. Last time I installed pairs of force-sensitive resistors in each of the 3 shoulder joints, and I combined those into an Arduino using the analog ins in pairs, and then did a bit of processing on the data to get a plus-minus swing. This time I need to do a bit of more post-processing on that data, send the data off over Bluetooth, and then start building the AI that decides what to do and sends the data back to the robot. So moving on from last time, what I've in fact done is decided to look at the difference in the values coming out of these pairs of force-sensitive resistors. So essentially what we've got here is a bookmark of the value, and next time we look at how much difference there is. And I'm running this whole loop with using millis and effectively multitasking to run at 10 milliseconds. So it looks at the change over 10 milliseconds, and then it thresholds it. So I've got a variable called change, and if that's basically bigger than 50, it sets a trigger value to a large number, and if it's smaller than 50, it sets it to a negative value there. And I've set them to plus minus 1,000, so we can see a big swing on the plot, and that's the same order as the rest of the sensor data. So of course I've got basically the actual raw data, the change in data, and a threshold which is basically binary, and I'll be setting those to 0 or plus minus 1, so I can just see if that sensor's been triggered or not. Obviously if it's not triggered, it sends it to 0. And if I look at a serial terminal right now, we can see the actual threshold. This is for joint 3, so this is the actual value we're getting out of that pair of force-sensitive resistors, and bearing in mind it's the one where the arm is resting down, so if I push it down more, we get a higher value, and if I push it up, we get a negative value. You can see the other values blipping there, so the middle column is the change, and the other one is whether it's plus or minus, and you can see those values shooting past. So it's probably best if we actually have a look at a plot here using Serial Plotter within the Arduino. Let's just stretch that out a bit. So the blue line at the top is basically the actual value, and of course that joint is resting down at the moment. I really need to put that mechanical packing in the joints, and there is provision for that, so we can make it rest better in the middle. The red line is the binary, so if I lift this up we can see a big square blip, so blue goes down, and the yellow line you can see there is the actual change, but basically the red line is now my sort of binary outputs, whether the joint is pushed in one direction or the other, and it only happens when there's a change, and then it settles back to 0. So effectively the plan would be if someone pushes the joint up, it will move up a bit, which then means they're not pushing it anymore because it's moved away from their hand, and if they push it again, it'll give me another value. Now I can look at the analog data as well, so if you just kept pushing it, it would keep applying force, the joint would keep moving away from you, but for now I'm just looking for a trigger really, so I can get some sort of reaction that basically it knows that joint has been pushed past the threshold. So I've now done that to all 6 sensors, so we can see now if I manipulate one joint, we can see we've got just that value in the left-hand column, but if I shake the whole robot, we can pretty much trigger all of them. So probably need some further filtering when we receive that data to see which one was triggered first, but on the whole that seems to give me some fairly reliable results. So as well as the Arduino reading those force-sensitive resistors, it also controls the lighting in the suit. And I've now wired that back in and added the NeoPixel library stuff back into my Arduino sketch. And I've written 2 functions here, one that sets the body colour and one sets the head colour, and those take in variables the RG and B values, and it just does a for loop cycling through the relevant NeoPixels, which are all in a chain, to set that. it's now reading serial data as well in the same way as the other module. So you may remember in the robot I've got two Arduino Megas, one in each side, and an Arduino Pro Mini in the head, and each of those listen on the same serial bus for an identifier, and when they receive data they make the joints move. So this Arduino now does the same, but it does the lighting, so that's reading in again the same 5 variables. Even though I don't strictly speaking need 5 for this, they all read in 5, which means they all read them and ignore them if they're not for that Arduino, and that clears the serial buffer. So that makes it super easy that they can all just read all the data, and it's always the same amount of data. So that's just to check that that worked properly. And then essentially what I'm doing, if the identifier for this is correct, which in this case is a letter R, is updating those variables into these light variables. And then I'm calling the functions basically to set the body and set the head. So the first character in the stream is an identifier, whether it's the head or the body, and then the next 3 are the RGB values. I'm then setting it back, the identifier back to 0, so it doesn't set them on every loop, and this loop runs 100 times a second. So if we were to try and set those NeoPixels, all of them, and there's basically a lot of them, that would slow down the loop a lot because it takes some time to execute that for loop. So now if I open my serial monitor, we can see we've got the data there, and if I now send some data to it, we can turn on the lights on the robot. So the identifier is R, so if I send a 1 to set the body, and I set it to, actually let's set the head first, and we're going to set that to green, so that would be RGB, the extra character and another R, and hopefully, yeah, there we go, that sets my head to green. If I want to set the body to blue, I can send it the 1, then that's R, G and B, and set the spare character and the R, and my body turns blue. So now I can send data to this to control the lighting, read those force sensitive resistors, and I can also send data. If I were to send the other identifiers, I could make the robot move. So now we just need to get all this data and send and receive over Bluetooth and start working on its brain, which is going to sit separately and be wireless. So now I've got my Bluetooth wireless link over here. This is just the module with the buttons on that activate different functions, and the robot is all the way over there. So if I press some buttons on this now, we should be able to see we can make the functions operate as before. So that's totally wireless. Now, I haven't built any lighting control in yet, and there's no means in this module to read any of the data back yet. So now I've just attached the USB to serial interface to my PC with that Bluetooth link on, so we've lost the Arduino with the buttons and everything, and I'm just dumping the data straight out to the serial terminal on my PC. So those are basically all of the values there for the series elastic actuators. So if I was to go and shake the robot, we should see those changing to 1s and 0s. I can now send data back for the lighting just by typing it in here. So if we go and set the head or the body, whichever one it is, we'll just set that to white for now. And there's the body. So basically it's totally wireless. Now I do have a choice here of whether to make AI that's set up on my computer, or perhaps it's a piece of hardware. So I could of course put those series elastic actuators into different modes. So I send some data to the Mega at the back of the robot, and it goes and basically gives me the analog data instead of the digital data, so without the threshold or something like that. So we're going to have to see how that goes. All that can be done in code. There will be other sensors on the robot, including vision, which we'll come on to later, and also stereo microphones. And again, that data will be processed locally and then sent back to the AI. The AI itself could be a computer program running on a laptop or something like that, just with that Bluetooth dongle stuck in, reading the data coming from the robot and sending back the actions that it wants the robot to take. It's not going to be very interesting though, watching me write some software for several episodes, and I'm not really that good at writing software. So instead I'm going to build all of this on Arduino, and I mentioned in the original part for this, part 1 for the series, I wanted the brain to resemble the holographic brain that Tony Stark has in the actual movie of Ultron in Age of Ultron in fact. And so what I want to do is basically make a 3D structure with lots of LEDs all over it that flash and sort of go up and down like bar graphs as Ultron is thinking. It'd also be really good if you could manipulate things in Ultron's brain by physically twiddling knobs and things to change all the emotions, as well as it getting feedback from the sensors. So basically we're going to build an Arduino based brain that sits separately, connected with Bluetooth, and that's what's going to control the robot. And don't forget, we've still got the motion capture suit we did early on, which is also going to influence it. Sometimes it's going to be in puppet mode, and sometimes it's going to read body language from a human wearer in the same environment. Right, this is the current state of Ultron's brain. It's an Arduino Mega, which did have the buttons attached that replayed the sequence of motions, but now it hasn't got buttons attached. I've piggybacked the Bluetooth adapter on the back of there, which is attached to the first, or in fact the second serial interface, serial 1. The first one is 0, and it's powered from a USB boost adapter. And I've put some pretty simple code on there for now. All the code does so far is to read in those series elastic actuator data, the 1s and 0s, and if it senses one, it just turns the head a different colour. So if I go and manipulate one of these, you should see the head turns white, and after a second it turns back again. Similarly, if I just hit the robot, it does exactly the same thing. Give it a good shake, and it senses at least one of those has been triggered. And remember, everything is actually running on this, all the decision making, reading that data over Bluetooth, and then deciding what lights to turn on, all in the code, and this is going to be its brain. So if I unplug the power from here, you should see a little reset there, and obviously we get nothing until I plug this back in again. So basically the robot is non-intelligent as such, and the brain does all the work. I've now implemented some code that makes the head turn in the direction wherever the force is coming from. So if the 3 sensors get triggered on this side, it turns this way. If they're triggered on the other side, it turns the other way. So there we go. If I lift this arm, it looks over, its head turns white. When it's red again, it's ready for sensor input. So it basically lets itself settle from its own wobble. It's pretty oversensitive at the moment. I probably need to tune that down. But if I go and give the other side a tweak, it looks that way. Just as you would if you're a human and someone kept poking you in the arm. So here's the code for that. So basically I'm reading in all of those bits of information from the series elastic actuators. Obviously if the identification matches again at the start and end of the data, it updates the variables. And then basically I'm just saying, there's 2 if statements essentially, saying if it's 1, 2 or 3, so it's the ones on the left side, then basically turn the head one way. If it's the other 3, 4, 5 or 6, then turn it the other way. And basically what it does is set some flags here so that basically its own wobble doesn't cause this to come round straight away and turn it the other way, and it doesn't sit there oscillating. So basically it sets this flag to 1 once it's done one of them, and these can never be triggered again because it's checking the flag is 0. They can't be triggered again till right down the bottom when it turns it back to 0. But first of all it sets the lights, and then it waits for this time called light time, which is about 2.5 seconds, so it's got time to turn the head. Then basically it sets it back to the middle, waits again for 1.5 seconds for all the wobble to settle in the robot, so it's not triggered immediately by the wobble of the whole thing, and then basically turns the lights off and sets the flag back to 0. Now these variables here for the lighting and the head position, basically at the bottom of this I've got these things here which write out the serial data. So I've got head, left, right and light, and these are functions which send that serial stream out. So further up in the code, this is very similar to a couple of episodes ago. I've got the functions here, head, left, right and light, and basically they send the identifier with commas and then the bits of data out, and those are printed out of the serial port, which goes over Bluetooth and comes back to the robot. That's just the tip of the iceberg in terms of sensing on its limbs, and there's going to be lots of other sensing built into the robot, including stereo microphones, and also something I've been asked about a lot is vision, using a little camera in its eye. There are various options for machine vision. We could get a USB webcam like this one and plug it into something like a Raspberry Pi or a BeagleBone or another little Linux computer, and we could use some open source software like OpenCV or some other machine vision software to interpret what's in the camera. This is something I might come onto, although as I've mentioned I'm not really a software developer. So I'm going for a much simpler solution, and that's the PixieCam. Now this is a camera that does all of the processing on the board for you. I've been following this project for a number of years. They're actually on version 5 now, and I think it's been about 10 years that something like this has been in existence, going back to version 1. And basically if you go and Google CMU Cam 5 or PixieCam, look for the Charmed Labs website, and you can find out what this is all about. But essentially this has got an NXP Cortex chip on it, a camera, some various other supporting components, and this camera will actually do the vision recognition on its own board. You can train it through Windows software or with a button on top to recognise various colours and combinations of colours, and it will track them incredibly fast and track multiple objects with a set of parameters. So I've set up my PixieCam here with a load of coloured balls in front of it, and I've put it into a sort of stand that's basically a selfie stick stand on a tripod, so it's just held there okay. We need to make a proper mounting to put this in Ultron, and I've got 4 coloured balls, so now I can go and assign those different signatures. So I'm going to make these 1 to 4, and it should start recognising them as soon as I do this. There are lots of parameters I can set here to set the threshold for each one, and those are on the settings tab below. So that's 3 and this is 4. So now it should recognise and track those objects. So you can see there's some similar colours in the background there, especially blue, but I've got this threshold setting at the bottom here. I've also got various settings for the minimum blocks that are grouped together, various other things, stuff about the colour code multipliers here. There's a whole host of documentation online. Also I can set white balance and brightness and things like that. So now if I move these objects around, we should see it tracks them incredibly quickly, and it can track hundreds of objects in a frame at a time. And I've got up to 7 signatures I think there that I can set for 7 different unique colours. So let's throw in some more red. And obviously my threshold here is pretty large, so it's grouping them together. If I move them further apart, we can see we probably should get those to be separate objects. Seems to work pretty well, and if I throw in a load more balls, it should track them all individually. And it does that pretty quick, so if I bounce one, I'll bounce that red ball, you can see how quickly that works. I believe that's actually tracking at 100 frames a second. Right, I can also do quite a good unique thing with some colour codes, and if I train colours as colour codes and put them next to each other, it'll identify them uniquely. So I've got one here that's red and blue, and it also tells me the angle. You'll notice theta changing there, as well as the coordinates. So that's quite good. So there's red and blue, and it recognises it if I lie down. And here I've got green and red, and it recognises that as another colour code. And the colour code is basically the colours that I've trained, the numbers next to each other. So that one is 1, 2, and the other one is 1, 3, which sounds about right. And if I've trained 3, then that gives that another unique code. And if they're in a different order, it gives it another code again. And they seem to detect pretty well most of the time, and if they're laid on the ground there. Let's just move those apart. So that's quite useful. So you could make up quite a lot of unique markers with the 7 different colours, put those all around the house and have a mobile robot or something, which basically can recognise the doorways. So you could have, for instance, colours of these either side of a doorway, and it'd recognise the orientation, or it could be a charging plug in the middle, or something else like that. And again, those track really quickly. So this is good enough to give Ultron some rudimentary vision capabilities. You'll notice I was having some issues with lighting and shadows there. It's quite sensitive. I was considering having an LED ring around the lens so it always illuminates what's in front of it. We could of course have bright white lights coming out of Ultron's eyes or something to cut out the shadows. But the main key thing about this is that the processing is all done on board by its microprocessor. So it comes with this cable that you plug into an Arduino to the ICSP header, which is an SPI interface, and then you can just strip out the data, having trained the camera, to get whatever you want from it. So I've now connected my PixieCam to my Arduino Uno. I'm just running the very basic sketch, which is the Hello World sketch in Arduino here, and this is basically identifying objects. It's connecting with SPI, initially in the Pixie library, and basically connecting to serial. So my serial terminal is 9600 board. And basically it's using get blocks, which is getting the information from the camera. So the camera does the processing and dumps out the data over SPI. So basically I've trained it to only recognise red objects, this red card. All the others have gone now. So you can see if I put this in front, it should recognise it. It says it's detected 1, and it tells me it's signature 1, and it tells me the coordinates, the X and Y there, and also its height. So if I bring it closer, height and width get bigger, and if I take it further away, they get smaller. And you should be able to see there's a red LED on there as well to identify that this object is in fact the first signature. And if I have multiple things set up, which I would have trained with the software, which is actually available for Windows, Linux and Mac, well, I can train it with the button on top as well, which is quite convenient. And there's more about that on the Charmed Labs website. So this is the rudimentary vision we're going to use, this red card to wave in front of Ultron, and hopefully we should be able to use this data through Arduino to make the head track. I've installed the camera in Ultron's forehead for now, for want of a better place. This might be head version 1, in which case I'd redesign it and put the camera in the eyes. There isn't actually space on this one. Or you might just get a slightly different forehead. So basically I'm sending that data off to the brain over Bluetooth, and I'm now making it track only yellow items. So I've written a very crude algorithm that modifies the head position when it sees something that's yellow, and it only tracks one object at the moment. Obviously there's a lot more we can do with this. So if I hold something yellow in front of it, its head should turn purple to say it's in tracking mode, and it only tracks very slowly at the moment. If I take it out of the threshold, a certain threshold, then it should turn red and the head should turn back to the middle. But for now it should track that item, which seems to work pretty well, and all it's doing is taking the XY coordinate of the item from the CMU cam and basically adding a little bit to the head position in those two axes to make it follow the item, which seems to work pretty well. But I have limited it so it doesn't go too fast, so if I move too fast and take it out of the threshold, it stops tracking. It doesn't just turn its head round and round and round and break itself. The variables are constrained as well, just so I don't break the mechanism, but that seems to work pretty well. So I've quite enjoyed doing that. I'm pretty happy that I can make this at least do something, and remember we can track different colour codes so we can label items. In fact, PixieCam are saying they're going to come out with firmware this year that it tracks faces. I don't know if it's going to recognise different faces, whether it's just going to recognise there's a face there, but that'd be really what I want, to track how many people are there, and I can see which one is biggest by the coordinates to see which one is closest and track that person's face. So that could be quite a good feature. So next time I'm going to work on building out the modules of the brain. It's going to be built in quite a modular fashion like we've done in this episode, so we can see the effect of each module as it's programmed in and how the robot reacts to it. So don't forget to subscribe to my channel for more updates on this project and lots of other projects. And also, if you'd like to fund my Patreon campaign, you can get access to some exclusive rewards, including a live broadcast with me and all my videos early. Check out patreon.com/xrobots. Alright, that's all for now.